Okay, so hello everyone, welcome back. We're just picking up where we left off in class, continuing with the final review, practice problems that I just kind of put together. We are continuing with single population mean hypotheses test. All right, so we'll do 2 examples like this in this category. So, number 5. A sample of students receiving financial aid was conducted on the time it took to process their application. The table below lists a random sample of application completion times in days. Assuming financial aid completion times are normally distributed, use a significance level of 0.05 to test whether the population mean response time is less than 60 days. Part A, what are the null and alternative hypotheses? So, first of all, the null. Now, we're working with population means, so we don't use the letter P. We're using mu. Right? And mu equals what?
0.60?
Not 0.60, but just 60.
Just 60.
Yeah, just 60, right? And then the alternative is we want to know if it is what? Less than, greater than, or different from? Less than 60. Good. It doesn't ask for it, but let's go ahead and include the direction, left-tailed, right-tailed, two-tailed? Left-tailed. All right, very good. Part B, are the normality criteria met? Yes. Why?
Because it says so.
Because it says what?
It says it's normally distributed?
Yes, because it says times are normally distributed.
I have a question.
Yes.
Which one is it that the sample size needs to be larger than 10 or sample size needs to be larger than 30? I feel like
So that was actually going to be my next question. For this one in particular, for population mean hypothesis tests, there were one of 2 ways to determine that. And one way was that we're explicitly told it's normally distributed as we are here. Or if it was not, then it needs to be greater than 30. And that is on this formula sheet here. It says off to the side over here. So mean, so I'm looking down here at the mean, right? And then I go down to the hypotheses test, and you could say it says requires n is greater than 30, or population mean is normal.
Okay.
Or population is normal. Okay?
What formula sheet is there on campus? Is that one?
This one's not on Canvas. This is one I passed out in class today.
Is this on the exam?
You can if you want. Yeah. And this is actually one from your book. I just photocopied it from your book. So worst case scenario, just rip it out of your book. Good questions. Any other questions here? Okay. Part C, list the sample statistics. And if such a question were to be on the test, I would list out what those sample statistics are. Like in this case, the sample statistics are, X bar, the mean, the standard deviation, and then N. Okay, that's the sample statistics that I'd be looking for. So those 3 things would be provided if such a question were on the exam. We don't have to do this in any particular order. Let's start with N. What's N? 14, because N is the sample size. Good. And then how do we find X bar and S? Put it into your calculator. Yeah. So bust out your calculators. All right. We go to Stat, Edit, clear out any old data that's in there. And then we enter in all of our data into L1. Hey, welcome. Do you need to include the 1, 2, 3, 4, 5, 6 all the way to 14? No, right? It's just stating, student 1, student 2, student 3. The only data you're entering is the amount of days it took to complete the financial aid application. So all you're entering into L1 is 61, 32, 50, 73, 51, and so on. So I'll give everyone a moment to type those in.
Are we rounding to 2?
Let's round to 3. Give everyone another few moments. Once you've got all your data entered, then you press Stat, go over to Calc, and then it should be your very first option, the 1 var stats. Enter, 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 and you should get the following. 59.714, and S is 13.106. Okay. Yes.
So we're not doing independent samples?
No. Any questions here? Okay, next calculate the test statistic, which is on your formula sheet. T equals X bar minus mu divided by S over the square root of N. And we have all the pieces of information here, so it's a matter of substituting it in. X bar we just found is 59.714 minus mu, which we stated in our null hypothesis was 60. All over S we found was 13.106 over the square root of N, which N we said was 14. This is calculator. Take your time entering into your calculator. Rounding to 3 decimal places, you should get negative point. Oh, I wrote that kind of weird. You should get negative 0.082. Give everyone a second to give it a try. Okay. So let's find the p-value. So the p-value equals, be careful when we are working with a mean hypothesis test. We no longer use normal CDF like we did previously. Which one are we using here?
TDF?
TCDF, good.
Wait, and that's because it's
Because we're working with mean, not proportions. And also, again, if you're using this formula sheet, it says right here's the T test statistic we just did, and then a little bit below says p-value TCDF.
That's the one you changed to.
wait, which formula sheet are you on?
So I'm on the formula sheet for exam 2. On the front side it says confidence intervals, and then on the back side it says hypothesis testing. And then for single population mean, that was the T equals, and then go down to the bottom, it says p-value TCDF. So TCDF, this is a left-tailed test, so we know it's going towards negative 99999, negative infinity. The upper bound is our test statistic, the negative 0.082. And then does anyone remember what comes next? The degrees of freedom, good. Now, we didn't already calculate the degrees of freedom, so I'm going to do it just right here in a different color. Degrees of freedom is, it's on your formula sheet if you don't remember, but how do you find degrees of freedom? N minus 1. So that would be 14 minus 1, which is 13. So when you plug in the degrees of freedom into your TCDF, that 13 goes there at the end. This should give you 0.468. Any questions? Okay. And remember, to get to TCDF, you again go second am I in the picture?
No,
Okay. You go to second distribution and then scroll down TCDF. So, what can you conclude about the null and alternative? Well,
So far.
our p-value is 46.8%, which is that less than or equal to 5%? No. Right, it's not. As I put that slash to it, it is not less than our level of significance. Therefore, it is or is not statistically significant? Not statistically significant. We reject or do not reject the null? Do not reject the null. And do we support or not support the alternative? Do not. Remember, this is the not, right? Do not support the alternative. All right, so since our p-value is not less than your level of significance, it is not statistically significant, we do not reject the null, and we do not support the alternative. Next, let's write a conclusion in the context of the problem. So, at a 5% significance level, the sample data do not, right, do not support the claim that the mean amount of time to complete the financial aid application is less than 60 days. Yes.
For the TCDF, where can I find that formula on the formula sheets? Is that exam 2?
Yeah, so on the exam 2 formulas, the front page says confidence intervals. The back page is what we're using, the hypothesis test, specifically the single population mean and then the p-value down there. Any other questions on number 5?
Can we? Never mind, I'll ask you later. I forget what we said was not gonna be on our first part. So it's gonna be, the first one is gonna be single population hypothesis.
Does anyone have a highlighter? Oh, can I borrow your highlighter?
Yeah.
So what I'll do is I'm going to highlight what we're using
Okay,
from each, and then you guys can come up and reconfirm it and mirror it.
okay.
So from exam 1, we're doing that hypothesis test, and we are doing confidence intervals. And also, I'm going to be trying to post later today or tomorrow another formula sheet if you wish, in which it's only containing the formulas needed for the exam.
Okay.
Oh, yeah, I need that.
But I know some people are also really comfortable having their little safety formula sheet, and they want to keep this also. So this is I highlighted what's from exam 1, from exam 2. From exam 2, it's this and that.
Okay. Thanks.
Yeah. If you guys want to pass this around real quick, you can. Just make sure I get these two back, please, just so you can see. So from formula exam 1, formula exam 2, what I have highlighted is what's needed on the exam. Yeah.
Are we allowed to put our, write the calculator steps for something?
No. Good question, but no.
Quick question.
Yeah.
What's the last sentence supposed to say? Complete the financial aid application is.
Oh, I missed a word. Yeah.
I was like, wait, what?
Is less
Less
than.
okay. It is less application.
Totally missed that word. Yeah. Mhm. Any other questions here? Okay. Next question, number 6, and we're still on the same topic, okay? Haven't changed topics yet. Imagine that a company sells portable walkie-talkie radios to construction crews. The batteries for these radios last for an average of 55 hours. The purchasing manager for this company receives a brochure in the mail that advertises a new brand of batteries. This new brand of batteries is cheaper than the brand that the company currently uses. However, the purchasing manager is concerned that the cheaper batteries may have a shorter average battery life than the current brand. The pricing manager installs 40 randomly selected batteries of the cheaper brand in the company's walkie-talkie radios. He finds that the mean battery life for the sample is 52 hours, with a standard deviation of 10 hours. He wants to perform a statistical test at the 1% level significance to determine whether the cheaper batteries have a shorter average battery lifespan than the average lifespan of the brand of batteries the company currently uses. Part A, or the null and alternative hypotheses. Okay, so the null is that mu equals, what are we starting off with? What's our baseline for comparison? 55, yeah. They currently have batteries that last an average of 55 hours. They're considering using new batteries, and they want to know if it's going to be less than 55 hours or not, because it's cheaper, right? It kind of makes sense. If a battery's cheaper, you're probably thinking it's not going to last as long. So how do we represent the alternative?
Less than 50.
Yeah, exactly. Mu is less than 55. Left-tailed, right-tailed, two-tailed? Left.
So because he said shorter, right? So that
Yes.
means that we're looking at less.
Exactly, yeah. So it
It
says,
doesn't actually say less.
it does not say less than. Yeah, good point. It says the purchasing manager is concerned that the cheaper batteries may have a shorter average battery life. Shorter means less than the 55 we currently have.
What type of question is this?
So we're still under the single population mean hypothesis test. Any other questions? Yeah.
Are we ever going to do independent samples for this chapter?
No.
Thank you.
Feels good, right?
Yeah. I don't know them in the-
Part B. Are the normality criteria met? Yes, why?
We know.
Good. And compared to the last example, it explicitly said normally distributed. So that's why the criteria was met. This time, it does not explicitly say that. So instead, you need to verify that the sample size is greater than 30. Is the sample size greater than 30?
Yes.
Yes. Sample size is greater than 30. Part C, list the sample statistics. Again, I would include this on the exam for you. I'm looking for X bar, the mean. I'm looking for S, the standard deviation. I'm looking for N, the sample size. Let's start with the sample size. What's the sample size? 40, because the manager installed the batteries into 40 of the walkie-talkies, right? Now, here's the tricky part. Actually, it's not tricky. It's actually easier compared to the last problem. In the last problem, you were given the data set here, and you had to enter in the data into your calculator to get X bar and S. Are you given the data set here to plug in your calculator?
No.
No. But you're just given it, right? Yeah, exactly. So we're told what the mean is. What is the mean? Yeah, it says right here, he finds the battery mean life for the sample is 52 hours. And then we're told what the standard deviation is. What's the standard deviation? 10. Yeah. So one of two things is going to happen in problems such as this. Either you're given the data, it's where you just plug it into your calculator, and then like how we did in the previous problem. Or if you're not given the data, you're going to be explicitly told what those values are. Okay, you just need to be able to identify them. All right, now we can calculate the test statistic, which recall from your formula sheet is x bar minus mu over s divided by the square root of n.
That's right. In what case do we use independent samples?
We're not on the final. It will not
So
be
it's
on.
not gonna be on it?
No.
Oh, nice.
For categorical or quantitative?
Either. We're just for both of them, we're only doing single, right? For both of them, we're only doing single.
Basically, we're gonna be just like using this. Kind of different. We're not gonna be doing independent samples on the final.
For hypothesis testing, we're only doing single. Okay, so let's plug in our info. X bar we said is 52, mu 55, all over s, which is 10, over the square root of n, which is 40. Alright, so plugging in all the values we have, you should get negative 1.897. Part E, find the p-value, which again, for this type of problem, we know we need to use TCDF. It's just coincidence it was a left tail again, but again, since it's a left tail, we go to negative 9999, negative infinity. The upper bound being the t-score, negative 1.897, followed by the degrees of freedom. What's the degrees of freedom here? 39, good, because it's n minus 1, your sample size minus 1. 40 minus 1 is 39.
Wait a minute, I can't find the TCDF. Oh, there it is.
I'm getting, rounding it, 0.033. Any questions? All right, we can conclude about the null and alternative. Well, our p-value is 3.3%. What was our significance level? 1%. So 3.3% is not less than 1%, right? Therefore, it is not statistically significant. So we do not reject the null and do not accept the alternative.
You mean support.
Oh, yes. Thank you.
Different word.
Do not support. Thank you.
I mean, it would
You could,
still say that, right? But
No, I want support.
okay.
Didn't I say support? Did I
No,
say
you said accept.
I said accept?
Yeah.
Oh my God.
So many-
Yeah.
it's time for vacation.
Yeah. Lastly, write a conclusion. At 1% significance level, the sample data do not support the claim. Sorry, I know it's tight on space. Do not support the claim that the cheaper battery lifespan is shorter than the batteries currently used.
So that it, for him, it would be worth it to switch.
Yeah. Yeah, save some money.
Yeah.
Any questions? How long are we here till?
4:30. What?
Okay, I have a feeling we'll probably finish a little bit early, but we're doing okay on time. Okay. Goodness of fit. So this is the new topic. Again, one of the free response questions will be a goodness of fit question. So number 7. A nationwide clothing store company, Get Fits, is having its annual half-price sale. As part of their advertising, the company sends out coupons in the mail to households all over the country. The coupons have a scratch-off feature with 3 possible outcomes. Offer A, 1 item half off. Offer B, 2 items half off. Offer C, 3 items half off. The company claims that the distribution of proportions is 60% of the coupons are offer A, 25% of the coupons are offer B, and 15% of the coupons are offer C. After reviewing complaints from customers, a consumer protection group wants to find out whether Get Fit's coupon claims are true. The agency hired a volunteer to record a random sample of 150 coupons mailed to people. The observed results are 75 of them were offer A, 45 of them were offer B, and 30 of them were offer C. And this adds up to the 150 coupons.
This is what we have to do by hand.
Yeah. You will conduct a chi-square goodness of fit test with the 5% significance level by answering the following. Part A, state the null and alternative hypotheses. Well, the null is going to be what the company claims. Okay, the null is what the company claims. So the null is they said offer A was 60%. Offer B, they said was 25%. And offer C, they said was 15%. So that's our null, what the company is claiming. That's our baseline. That's we're starting off assuming that what they say is true. The alternative, well, remember, the alternative, the customers are upset about this, right? Because they think these proportions aren't right. They're thinking that they're getting gypped on these coupons. So the alternative would be remember, this one could be slightly different, but it should be very near, along the lines of at least one of the coupon proportions, claimed by the company is not true or not correct.
And this is exam 3, correct?
Mm-hmm. Yeah, this is coming from exam 3. Any questions so far? Okay, part B. Complete the following table, rounded 2 decimal places if needed. So we have the observed, and the observed were just re-included for us here. Like offer A, 75 is right there. Offer B, 45 right here. Offer C, 30. That was the observed, right, when they took their sample. How many were they expecting, though? How many were they expecting? Does anyone recall the formula to calculate the expected?
N times P.
N times P. And it is on your formula sheet. Right? If you look on the third formula sheet, in case you forgot, expected right here, E equals N times P. So,
It,
mhm.
it just says E, can we write expected?
Yes.
Oh, it says it above, but still.
So, what it's telling you to do is to take your sample size and to multiply it by each corresponding proportion. So, this is 150 times, for coupon A, that was 0.60, which gives you 90.
Wait, how did you get the 150?
That was your sample size N. So, it's N times P.
Oh,
And it's a random sample of 150. For coupon B, sample size is still 150. And out of the 150, we expected a proportion of 25% or 0.25 to be offer B. So 150 times 0.25 is 37.5. And lastly, offer C, 150 times 0.15. And that would be 22.5. Any questions there? Yes.
Where do I find the formula for the expected?
So on the third formula sheet, it's right there.
Okay.
Yep. And then lastly, we use this formula here to determine the contribution, where O is the observed, this column, E is the expected, we just calculated. So you substitute it in. So for example, I'm not going to write it out for every single one, but I'll just do it for the first one because of the space. So for the first one, you'll do 75 minus 90 quantity squared all over 90. All right, it's calculator, plugging that into your calculator. 75 was the observed, 90 was the expected, substituted in. That'll give you 2.5. Similarly, for offer B, substitute in 45 for O, 37.5 for E. Using your calculator, you should get 1.5. And lastly, for offer C, substitute 30 for O, 22.5 for E. You should get 2.5.
Just a quick question. So the parentheses on top of the equation, like, those are vitally put into.
Yes, make sure you include the parentheses in your calculator. If you don't include parentheses, it will give you the wrong answer. Okay. Part C, state the value of the chi-squared test statistic. So how do we calculate the test statistic? Anyone recall?
Stat test and all
Not the p-value.
What's the chi-square?
the, well, chi-square test.
We're not doing that just yet.
Isn't it the total of the last comment?
Yes, you have to add this up together, right? To get the test statistic, you take your contributions and add them together. So 2.5 plus 1.5 plus 2.5. And that's 6.5. Okay. Part D, what are the degrees of freedom? So the degrees of freedom is equal to K minus 1, where K is the number of possible outcomes there were. How many possible outcomes were there? 3, because there were 3 coupons, right? Offer A, offer B, offer C, 3 coupons, 3 options there. So 3 minus 1 is 2.
Why do we call it K now?
So before N remember was a
Specific
sample
for
size,
sample size.
and
We have to call it
K,
something else.
yeah, exactly.
So they just picked K like
Yeah, they just
randomly?
picked K, yeah. Part E, use your calculator to find the p-value. All right, so our p-value equals, what CDF are we using this time? Yeah, chi-squared CDF. And remind me, chi-square CDFs, they are always
Right tail.
right-tailed. Good. So what goes first is your test statistic, which we said was 6.5. Since it's right-tailed, it then goes off to positive infinity, or 99999. And then lastly, it's the degrees of freedom, which we said was 2. And that is 0.039. Part F, what can we conclude about the null and alternative? Well, our p-value is 3.9%. What's our significance level?
5%.
5%. So that is less than or equal to 5%, meaning it's statistically significant. So we reject or do not reject the null? We reject the null, and support or do not support the alternative? Support the alternative. Good. Part E. State a final conclusion in the context of the problem. At 5% significance level, the sample data support, because we're supporting here, the sample data support the claim that the proportions of coupons being, we had said it was 60% offer A, 25% offer B, and 15% offer C are not all correct. All right, because that was our alternative claim. We were saying that no, these aren't all correct. So I just relisted them out, say our sample data supports the claim that these proportions of coupon offers is not correct. Any questions? All right, so those were the two. Oh no, actually we have one more. Never mind. Getting ahead of myself. Y'all ready for the next one? Yeah? Okay. Let's do it. So we're doing another goodness of fit. Okay. Right off the bat, I'm going to tell you there's major errors here. When I made this, I accidentally copied over the same table here as the last problem. You see that?
Yeah.
So if you tried this on your own earlier and you're like, what the F? Like, that's what happened. Okay. But we'll fix it when we get to it. Okay. A teacher figures that the final grades in the chemistry department proportions that are distributed as follows: 25% A's, 25% B's, 40% C's, 5% D's, and 5% F's. At the end of a randomly selected semester, the following number of grades are recorded for 160 students. 42 got A's, 36 got B's, 60 C's, 14 D's, and 8 F's. If you were to add that up, that adds up to 160. Test the claim that the grade distribution for the semester is different than what is expected, Test at a 1% significance level. All right, so what are the null and alternative hypothesis? Well, the null, I'm going to write it horizontally this time because I'm going to run out of space. So the null is what the teacher initially figured the distributions of the grades would be. So she thought that A's would be 25%, B's would be 25%, C's would be 40%, D's would be 5%, and F's would also be 5%. Then for the alternative, we'll say that the teacher's grade distribution is not all correct. All right, we're thinking that at least one of them is off.
Yeah, so we could write it like that,
Mhm.
like where you said, at least one of the teacher's distributions is not correct.
Yeah.
So when doing the alternative, it has to be like within the context of the problem. It can't just be
Yeah.
like At least one of the populations is different, right?
No, I'd like it to be in the context of the
Do
problem.
we lose points if the answer is like not in the context of the problem,
We'll see.
or? Okay. Okay.
But we have to like, if we're gonna say like at least one of the distributions of grades is not correct,
Yeah, since you said grades, that's the
Yeah.
context.
I
Yeah.
don't have to say teachers.
No.
Okay.
All right, part B, complete the following table as we did before. So this is where we're off. So, because we're not doing coupons anymore, right? This is the grade. So grade A, B, C, D, and F. So you have to add in those two grades. And then the observed. What was the observed for A? Grade A's?
25%.
42.
42 for the observed.
Oh.
What is it for
42.
B's? 36 for C's, D's, and 8. Okay. Yeah, because that's from what was given. That was what was observed. So remember, to calculate the expected, you do N times P, the sample size times the proportion for that category. What was the sample size? 160. So we're going to do 160 times for A. From the null hypothesis, A was supposed to be 25% or 0.25. So 160 times 0.25 is 40. For B's, it was 160 times 0.25 again. So again, 40. For C's, 160 times, let's see, the C's were 40%, so 0.40, which is 64. For D's, 160 times 0.05, it was only 5%, that will be 8. F's were also 160 times 0.05, so you get 8 again.
And so this table, these numbers up here, this is our observed, right?
Correct. In that little mini baby table. Once again, we take this data, substitute it into this formula to get our contributions of each category, where O is the observed, E is the expected, and you do them one at a time. So first for the A's, again, I'm not going to do it for all of them, I'm just going to do it for the first one, writing it out. It'll be 42 is the observed, minus the expected 40, quantity squared, all over E, which was 40. Enter that into your calculators. That'll give you 0.1.
I have a question.
Mhm.
Is it the same if we do the up arrow and then just type a 2 as then putting the, yeah, it's the same, right?
Type of,
To square it?
yes.
Okay.
Yes.
And then our expected is,
I'm going to go ahead and fill in the rest, and I'll give you guys a little bit of time to try these in your calculators to make sure you're able to get it. Anyone having any questions here? Okay. Part C, state the value for the chi-square test statistic. So how do we calculate that?
So,
Yeah, you add the sum of the contributions together here. So chi squared equals 0.1 plus 0.4 plus 0.25 plus 4.5 plus 0. I'll give you 5.25.
I have a question. On the exam, do we have to write it out, or can we just like solve it and write it out?
You can just solve it, but
Okay.
that's the whole thing, that like, what if you accidentally miss a number? Then there's no room for partial credit,
Okay.
right? Part D, the degrees of freedom, which was k minus 1. What's k in this case?
The options.
5.
There's 5. Why is it 5? Yeah, there's 5 grades, right? A, B, C, D, or F. There's 5 categories. There's 5 options. And then 5 minus 1 is 4. What is the p-value? P-value equals chi-squared CDF, where lower bound is your test statistic, 5.25, goes towards positive infinity, followed by the degrees of freedom. And you should get 0.263.
Where are the CDFs again?
The second distribution.
Okay.
Yeah, to get to the CDFs, you do second distribution. Part F, what conclusions can you make about the null and alternative hypotheses? Well, the p-value is 26.3%. What was our level significance? 1. So definitely a no, right? 26.3% is not less than 1%, meaning it is not statistically significant. So we do not reject the null and do not support the alternative. Part G, state your conclusion in the context of the problem. At 1% significance level, the sample data do not support the claim that, and what was the claim? The claim was the grade distributions are not 25% A, 25% B, 40% C, 5% D, 5% F. Maybe we could say are not all that.
Do we have to list them out like that, or we can say are not what is stated in the null?
Well, read it to me fully.
Or not all the
At
same.
a 1% significance level, the sample data does not support the claim that the grade distributions are not what is stated in the null. That's okay.
I'd like it listed out. Yeah.
Yeah, because what if you can't understand the null?
Yeah, because at this point in time, like when you're in the context of the problem, it's like you're sharing out your answers to some random person who is not participating in this at all, and you're just trying to give them the overall result. If you start talking about the null and all this other stuff, you're gonna lose them.
Okay.
So wait, why does it not support it though? I mean, if we're supporting like the null basically, on the context of the problem, wouldn't it be that it is in favor of like all those grade distributions being equal to it?
Correct.
Yeah, we end up having a double not in our conclusion, right? The sample data do not support the claim, right? And then what was the claim? That the grade distributions are not. So doing that double not is essentially almost like saying, oh yeah, just go back to the null.
Yeah.
But we're not rejecting the null is not the same thing as supporting the null.
Right.
Okay, so our conclusion is not with regards to the null. Our conclusion is just with regards to our claim. Does our claim have any footing? So that's why we're focusing on the claim here.
Doesn't make sense to me. It's really weird.
This one's weird.
Yeah, does it
This one's
say-
weird because we have a double not in our conclusion. We're
And
saying,
that's like automatic confusion.
yeah, so we're saying that the sample, so there's like consider it separate. Our sample data does not support the claim. What was the claim? The claim is that the grade distributions is not 25% A, 25% B, 20 whatever C, and so on.
It's the same thing Chris said his question about this entire semester. He's like, he doesn't get it.
It's yeah. It's like the two negatives make a positive type thing. Yeah.
Okay. Sure. I should have remembered that.
Okay.
I love the Spaceballs reference, by the way.
Where?
So
From the
similar to
desert?
what you said. So then
The
is
Eagle
it
Space
okay
or
if I
Dark
see it as,
Helmet?
like, if I'm
You
not
didn't notice that? They
supporting
talked
my
about Dark Helmet
alternative, then
and
like
Ludicrous.
that was. I don't know what I'm because the way I understand it is like.
Can I read it?
If I'm not supporting, I remember the thing.
Oh, okay.
But I mean, like, if I'm not supporting the alternative, then automatically I'm putting on the bottom that I'm not supporting the claim, because that's like, I don't know, I feel like.
Yeah,
if I
you're
look
not
at it-
supporting the claim.
If I look at it as like that I'm not supporting my alternative, then I'm not.
The alternative
I don't
is the
know.
claim.
Yeah, the alternative is the claim. So when you're not supporting the alternative, you're not
Then you-
supporting the claim.
Yeah.
Yeah.
So basically what you're saying is like, if you don't support the alternative, don't support the null either, like on the context of the problem? Or?
No,
Oh, well,
that's not.
This problem is kind of.
No, they're two separate things. So all I'm saying is do not reject the null.
Okay.
I'm not saying I'm supporting it. I'm not having evidence in support of it, but I don't have anything to just toss it out and throw it out the window and say this is garbage. That's what we mean by do not reject the null. But we don't elaborate upon it in our final conclusion. Okay, I'm not touching the null in the final conclusion. In the final conclusion, I'm just talking about our claim because that's what we tested. So I'm basically just restating whether or not I support the claim. So I'm saying I'm not supporting the claim, and then restate what the claim was.
Okay.
I was trying to explain how I was looking at it, like to finally understand it, because I was like, struggling with it too, but I lost my
Is this type of problem gonna be on the test, Professor?
Say again?
Is this type of problem gonna be on the test?
Yes.
I'm pretty sure.
Yeah.
Okay.
Yeah.
Can you like dock down the points
them up
for the
once you get
context?
Sure.
I'm gonna try to put it.
Yeah. Do it. Okay, guys. You ready for the next topic?
Oh, it's the worst.
The linear equation. Okay, here we go. The literary club is looking to raise funds, and they are considering selling coffee mugs to raise money. Other clubs have shown that if they can sell 100 coffee mugs, they will have a total of $225. And if they can sell 250 coffee mugs, they will have a total of $540. Find the linear model that represents how much money they have, A, as a function of mugs sold, X. All right, we want a linear model, which usually that's y equals mx plus b, but it's explicitly telling us to use a instead of y. So a equals mx plus b, where there's two things you need to find. You need to find m, the slope, and you need to find b, the y-intercept.
What if we were to use a capital M? Is that right?
Oh, God.
I do that all the time.
I'll just assume that
There's
you
so
meant
many
little
different
m.
notations in math, you never know, it could mean something completely different.
So on your formula sheet, I don't have it with me, but on your formula sheet, there should be the formula to calculate m, the slope, which is y2 minus y1 over x2 minus x1. So in order to get the slope, you need 2 points. Okay, you need 2 points. You're going to get the info to form those 2 points from the problem itself. For instance, we're told 100 coffee mugs was $225. So 100 coffee mugs is $225. Then I was also told 250 coffee mugs is $540. So that's the second point. 250 mugs is $540. Those are my 2 points. Yeah.
Okay, so in order to identify which of our variables are X and Y, we need to really, or at least I need to really read the problem.
Yes.
I should be really reading the problem for every single one.
Yeah.
Okay, because like
Have to
I'm
go
like
in order
completely
like that,
lost.
like-
you
The
know?
order matters.
Order
It
matters.
cannot be 225, 100,
Sold.
for instance.
Okay, yeah. Well, necessarily like our X1 would be like 250 and our Y1 would be 540.
Yeah, that's what you said there is fine.
Okay.
Yeah.
Okay.
But it doesn't say what, it doesn't specifically say Y is the,
It's always
is the money.
that.
No, it doesn't. It's telling you that it's remember Y is the same thing as A in this case, right? We're
It's
just,
also order.
but because think of it as in terms of your input versus output. In order to determine the amount of money the club is going to make,
Okay.
you first need to know how many mugs are sold. So you need to know how many mugs are sold first, your X, to then be able to determine how much money you get. Okay.
Sorry, compared it to the exam, so is it like the inverse of what we did on,
This is actually question number 1 from the exam. I think it's number 1.
It is.
Yeah.
oh, you put one left, I'm
And we have to go backwards.
Okay.
So let's say our Y2 would be 540.
Yes.
Yeah. So I chose to call my first point here my x1, y1, or a1, and then my second point x2, y2. So now that I have those labeled, I'm just going to plug them into the slope formula. Okay. So 540 minus 225 all over 250 minus 100. This will give us 315 over 150. Using your calculators, 2.1. Yes.
Why can't it just go in order?
Why can't
You
what
know
go
I
in
mean?
order?
Like, why can't our because if I was looking at it, like I would assume that my my first.
You mean like Y2, Y1?
would be 225, right?
Okay, if you were to have done this, you get
Yeah.
the same thing.
Oh.
You get the same thing.
Alright, so
In general, though, they write that first formula because when students are typically first introduced to this concept, we are working with positive slopes usually, which to get positive results. That would be the order of the formula. So to try to make it less complicated when students are initially learning the material. But technically, you could do y1 minus y2 over x1 minus x2 and get the same answer.
Okay.
So we have the slope. Remember, that's one of two things we need. We need the slope and the y-intercept. So I'm going to take that slope and plug it back in to my equation. A equals 2.1x plus b. So what do I have left to solve for? B, right? I have to solve for b. To solve for b, I need to plug in a value for x and a. To do so, plug in one of these points, either this point or this point. It doesn't matter which one you do. If you choose one different from me, your work along the way will look different, but your final answer will be the same. So I'm going to just work with the first point. So I'm plug in 100 for x and 225 for y, or in this case, a.
How do you know that, like, which one to plug in?
It doesn't matter.
Okay, so you can do like reverse as well. Like 225 for x and 100 for
No,
y.
no.
You can't do that.
Because remember, your ordered pairs are always of the form x comma y. Always.
Oh, okay.
Or in this case, since we're using a, x comma a.
Oh, I see. Okay.
So then we just solve that straight across.
Yeah, we'll start solving for it. So I'm going to plug in 225. 225 equals 2.1 times x, where x is 100, and then bring down the plus b.
I was thinking that was an A.
The A is the Y.
Then why is it the A? Oh, wait, okay. Oh my God. How many points is this one worth on there? 4 and 6.
I don't know.
I hate this. Okay.
All right, so 225 equals, you could simplify this guy right here. 2.1 times 100 is 210. And then bring the plus b. To get b alone, you subtract 210 from both sides of the equation. You are left with 15 equals b. So sweet, I found the other thing I was looking for. So overall, the final equation is a equals 2.1x plus b, where b is 15.
See, that makes a lot more sense now. I don't know why. Yeah, I remember on the exam I was struggling with that. So,
Makes sense now though, so that's
Yeah.
good.
I think it's just the setup, like when we say the question, you don't really think of it to do x and y first,
Mm-hmm.
like the y2 of it.
Yeah. Yeah, the key here was how it says, find the linear model. Linear model, you should be like, oh, y equals mx plus b. Or it says find the equation of a line, right? Something along that. Okay, let's do number 10. So use the graph to find the equation of a line. All right, so I know that's going to be y equals mx plus b. And again, in order to do these calculations, I need at least 2 points. It's any 2 points of your choosing in this case, because like in the word problem, it gave you the information to derive the 2 points. And here you're given the graph, and as you can see, you're given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points to pick. My recommendation is to not pick a point that's like in between, because you're gonna have like decimals, you know? So let's pick some like nice points. What points do you guys want to pick?
What if we were to graph it first? It doesn't work that way.
It
So-
doesn't, so we have to graph with the values that we found,
How about
not the
You don't
values
have
that
to
were
graph-
given.
You're not graphing it.
You're not graphing anything.
You're just using these points
Yeah.
to plug in to your y
Yeah.
equals mx.
That's a really nice point. All right, that point right there is that, well, be careful though, it's not 0, 8, it's 8, 0. So that's a good point. What's another point you want to pick? 4, -1. Let's do that. 4, -1. So again, any points of your choosing, we picked 8, 0, and we picked 4, -1. Okay. So I'm going to call this my x1, y1, and my x2, y2. And now let's calculate the slope. So the slope equals y2 minus y1 over x2 minus x1. So in this case, that's going to be 0 minus a -1. So be careful there. 0 minus -1 all over 8 minus 4. Minusing a negative becomes positive. So positive 1 over 4 or 0.25. So we found the slope, plug it back in. Y equals 0.25x plus b. And we can now use this to find b. So plug in a point of your choosing. It does not matter which. You guys want to plug in the 4, -1, or do you want to plug in the 8, 0? 4, -1? Okay. So I'm going to plug in 4 for x and -1 in for y. So -1 equals 0.25 times 4 plus b. -1 equals 0.25 times 4 is 1. Feel free to use your calculators. And then you still have the plus b. Subtract 1 from both sides. -1 minus 1 is -2 equals b. So I found my slope. I found the y-intercept. So y equals 0.25x minus 2. And that is the final answer. Any questions there?
So I'm noticing that like we're doing the same steps we did before,
Mhm.
previous, just like a different graph.
Yep. Alrighty, guys. On to the last topic. The last topic being solve an inequality. Okay, solve an inequality. So number 11. 8 minus 3x is less than or equal to 7x plus 58. You have many options for how to start here. You can start working with the x's first. You can start working with the constants first. It's really up to you. Personally, I like to start working with the x's first. So I want to get my x's only on the left-hand side. So I need to get rid of the x's that are on the right. To do so, I'm going to subtract 7x from both sides of the inequality. So that way the 8 comes down. Negative 3x minus 7x is negative 10x. Less than or equal to, bring down the 58. Now, our goal is to get x alone, so let's subtract 8 from both sides of the inequality. You're left with negative 10x is less than or equal to 50. Again, still trying to get x alone. Divide both sides by negative 10. Those negative 10s cancel. You're left with x. What happens here? Sign flips. Good. X is greater than or equal to 50 divided by negative 10 is negative 5. Remember, anytime you multiply or divide both sides of the inequality by a negative number, you flip the sign. All right, and we have one more. Similarly, solve the inequality. Negative 4x minus 5 is greater than or equal to negative 29 plus 8x. Again, personally, I like to work with my x's first. We need x's to only be on one side of the inequality. So I'm going to subtract, I'm going to subtract 8x from both sides of the inequality. So that way those 8x's cancel. Negative 4x minus 8x is negative 12x. Bring down the minus 5, the inequality, and the negative 29. So now, to get x alone, I'm going to add 5 to both sides of the inequality. That way these 5's cancel. So negative 12x is greater than or equal to negative 29 plus 5 is negative 24. Lastly, get x alone. Divide both sides by negative 12, so those cancel. You have x is less than or equal to, sign flip, because we divide both sides by a negative number. Negative 24 divided by negative 12 is 2. Let me see. Question?
Yeah, I wonder if you could check where I went wrong.
Okay, yeah, let me check where she went wrong and then I'll check yours. You add 8x to both sides. Good. 24. No, that's the same thing.
But I didn't do it by a negative, my sign didn't flip.
Yeah, but your end result, your answer is the same. Notice how the inequality is open towards the 2.
Yeah. Oh,
Inequality is open towards the 2. You just wrote it reversed. It's the same thing.
okay. Oy.
On this one? So you added 3x, that's 10x.
So are you gonna be able to come and check on
the 8
mistakes if you
I
didn't
think
notice?
50 divided by
I'll just need to be alone longer. My husband will flip out.
So you keep the sign the same, because you didn't divide both sides by negative, you divide both sides by positive. So the sign stays the same.
I was gonna ask you, any like,
I might be able to send it now.
Anyway,
like both have terms?
that's everything that we've done.
Are you gonna
But
be
do you think like, would it be from these sections you're providing, or are you saying in general?
In general.
That's what I'm saying.
Are you gonna be like, taking away your wheelchair?
Yeah, probably all 4 points. No, I
You caught
like,
it.
what sections you should look at for like other folks, and how it's like, you need to know stuff like that.
God rest his soul.
Yeah, it's gonna be like, whatever, yeah. I'm not gonna lose 4 points
I don't
over
feel good.
It's that one.
All right, I'm going to stop the recording.
No, I hope it was a